Welcome to this new session on Hackfest 4.3 on closed loop operation, uh, adding auto scaling, alerting to VNFs and the related stuff. So we'll start from where we had left in the session in the monitoring in the day one. I hope you still remember the day where my colleague Fabia was providing you, the features about how we in OSM is able to collect matrices using the service assurance module. We are able to use that to monitor it in the dashboards. We have some new and interesting matrices that we are able to collect apart from the infrastructure matrices, like the SNMP matrices to the SNMP protocol. We are able to collect, and we have created a new SNMP adapter, but in a very different way through the Prometheus job exporter. So you might recall all of them. So we'll build on top of that. So once the metrics is collected, the next thing is about how you use the matrix. I mean, it is just for dashboarding, or you can go beyond that. So that is about the what we are going to talk about in this session. That is what we'll be like exploring. What else we can do. So I will start with two current features of OSM, which is auto scaling and alarms. And these are two very important features that build on the matrices that are getting collected. So let's go ahead and explore this. Okay, so to understand auto scaling and alerting, we need to understand what is this service assurance module all about. Might be few of you already know from the last session, and few of you might be very new to this. So let me give you a quick overview of what this service module is, and then from there we'll see which are the elements which are relevant for this particular session. So we have three core modules of service assurance: the MON, which stands for the monitoring agent that monitors all the matrices and puts it into the dashboard so that it can be viewed by the user of the OSM. Second is Paul. Paul is the policy agent, and that is very important for this session because everything that is related to scaling, that is related to your alerting, alarms, everything is driven by Paul. So it is the policy engine of the service assurance, and it decides how to auto scale, how to send the alarms, and so on. And finally, Prometheus. So it is more than just a database. So Prometheus primarily is a time series database, but with some very unique additional functionalities that you might know. One is it provides you an additional exporter capability that we have started leveraging now. So the exporter are the way to export matrices from an external agent. So what we have done, you might have seen in the previous session, is we have created a exporter for SNMP so that all the SNMP related matrices from the VNFs can be collected through Prometheus. So this is a revised architecture that we are working on so that the matrix collection is much more scalable and much more faster than what it is today. And then it has a few other things like alert manager, which we are still not using it, but going forward, this is also we are looking into the architecture, how we want to use the alert manager. And finally, it has integration with external querying system like Thanos. So we'll not be talking about all this, but we'll be treating primarily Prometheus as a time series database here for service assurance now as it is today. But why I was talking about this additional features is we are exploring these additional features for for the new architecture that we are creating, is a more scalable service assurance architecture. Okay, and then there are a few other important components. One is the Grafana. So Grafana is a dashboarding tool primarily for the time series data, the data that comes along time. So all the matrices that we have are collected are time-stamped, so it is easy to show them in Grafana. Grafana shows very nice charts. You might have seen it in the previous call. And one more feature that OSM has that we primarily don't use in our systems, but it is a nice to have and you should start exploring, is the ELK. So ELK is primarily for the log analytics. So it is the Elastic Stack, and the ELK stands for the Elastic Search Graph, Elastic Search Database, the Logstash agent, and the Kibana dashboards. So this is an additional, I will say, a mechanism through which you can collect data and show in the Kibana graphs, primarily for the log data. This is a nice to have that you can explore, but it is not used extensively within OSM. Another new model that have come up in release 8 is the placement model. You have heard Lars talking about that in the previous session, which decides where to place the module or where to place a network service in a multi-VIM scenario based on the cost calculation. Okay, so let's move forward and see how these are related to the subject that we are going to talk about here. So I will be primarily talking about two different aspects of service assurance that uses these metrics collection infrastructure that you have seen in the previous slide. One is auto scaling. So auto scaling is based on a policy. The policy can be like a certain threshold. When it exceeds, you can scale out or scale in. So it can either is going above the threshold or coming below the threshold. So we'll do a scaling. So so we can scale the VNFs to add video. We'll also do a hands-on here, depending on where you are on the network slice. So we'll be using the same network slice that you have used and created in the first session today to show you how the scaling can work. So depending on whether we are able to finish within this time, then the network slices, then maybe we can use those network slices. So for the scaling, we define a scaling group. We'll come to that in a moment, but we define in the VNF descriptors, we define the policy for scaling. So which matrices I will be using for scaling, how I will, or what are the threshold I will use for scaling, what will be my cooldown period, and so on. And we support both Vim and VNF metrics today. And there is another less known feature, but is very important, I will say, is manual scaling as well. That means through an API, you are able to scale as well. That means you are not using a scaling policy. You are not using a metrics behavior to scale, rather than you are scaling it based on just invoking an API. So that is important when you are building an intelligence layer or an application that is outside OSM, and that decides when the scaling can happen. For example, you are creating a application that decides on some of your enterprise matrices that are outside the control of OSM, but you want OSM to scale for that. For example, say there are more people coming in today in the office, so I scale out so that I can cater to more people for a given service. So that is a manual scaling also that is possible. Alarms are, I will say, another feature like scaling. So while scaling means you are scaling out the VNFs to have additional views for additional capacity in the network service. But alarms is when you want to call a webhook and intimate or indicate this problem to an external entity. For example, the service provider may have a service assurance system, or maybe they have an OSS, or they may have an alarming tool where in the knock they see all the alarms. So you want this alarm to be like visible there. You want to inform their knock team. You can do this by invoking certain webhook or certain API in their alarming system. So that is the two I'll say procedures that we have today. The auto scaling, which is primarily when there is a threshold that is breached for a particular mattress, you increase or reduce the number of videos or the VNFs or the VMs inside the VNF. And alarm is just calling a external webhook, but both are based on policies or rules, I'll say. Okay, maybe we can just revisit the MON architecture a bit in detail to understand what are the like aspects of MON and POL that are helping you to create. Because when you are seeing things scaling, maybe sometime it is not working, or you want to know more about this, you should know exactly where to see in the service assurance, so that you know like this is what it is meant to do, and this is it is doing correctly or not doing correctly. So and there are three primarily modules of MON today. One is the MON collector. So what it does is it collects the monitoring parameters either from directly from the VIM or the SDN controller, or from the VCA, which is the proxy charms from which it collects the matrices. So VCA is primarily when it is VNF. The VIM and SDN controllers are more infrastructure. So it directly collects from the VIM and the SDN controllers. But with the VCA, it collects from the MON collector. Okay. And then the MON collector collects this data, puts it in the time series database, which is Prometheus right now. So, and then there is a MON evaluator. The work of MON evaluator is to evaluate periodically the matrices and to understand that it is violating any threshold or not. For example, I have given a threshold of 60% of CPU on which scaling should happen. That can happen, or that should happen or not happen, will be decided by the evaluator. So what evaluator does, it gets the matrix from the MON evaluator and the policy from the common database, and then it decides through a rule that whether I should scale or not. So if it has to scale, it will tell to the Kafka adapter and or the Kafka bus, and from Kafka bus it will go to POL, and then from POL either it goes to the LCM or it goes to a webhook, depending on it's a auto scaling or it's a alarm. But the evaluator per se is actually evaluating whether there will be a need of any action for this matrices or not, based on whether it has hit certain rules that calls for an action. There is a MON server. The MON server is primarily for writing new rules in the common database. For example, in the VNF, I have created a new policy. That new policy comes to Kafka, and from Kafka it comes to MON server, and MON server registers those new policies to the common database. So these are the kind of like three different main modules: the MON collector for collecting the matrices, MON evaluator for evaluating the matrices, whether it is breaching any threshold rule, and MON server is for writing new policies inside this.
Hello.
Hello, Mr.
Hello. I think we lost Subhankar. Who's calling me?
Any
Yeah,
question,
no, we
just let me
cannot
know.
hear you.
Let me also see
Uh,
in Slack.
Subhankar, we lost you for the last 2 minutes.
What collector looks it is hope it connects. Okay, I'm back. Okay, so we had seen the MON architecture. The next one is the Paul architecture, which actually does or takes the action on behalf of the MON evaluators. When the MON evaluator evaluates that an action has to be taken, the action is actually taken by Paul. So what Paul does is it gets a request from the Kafka bus. So MON evaluator writes to the Kafka bus sends it from Kafka's Paul agent gets it, and then it decides, like whether what action has to be taken, right? Again for that network service. So if some action has to be taken, so it will again send the request back to Kafka and will be picked up by either the LCM, the lifecycle manager for auto scaling, or it will go to a webhook. Okay, so this is the Pole architecture. Now we have seen the MON architecture in detail and the Pole architecture in detail. Now let's see all of them together to see how this auto scaling actually works on ground, right? So for the auto scaling to happen, first of all, the northbound interface writes the alarms, etc., here in the common database, and then say so this is a new interface that is coming for the northbound interface for querying alarms, etc. But the actual activity starts here, number one. So what happens is the MON evaluator continuously looks for any alarms, any policies that are coming. So, okay, so who writes into the common database? The common database, whenever a policy is created inside the VNF descriptor and it is launched, it comes here, or through a northbound interface, new alarms can be created. And the MON evaluator evaluate these alarms continuously to see like what kind of new rules, new threshold rule that have come in. Second, it queries continuously the matrices to find out, as I said in the previous slide, that the rules are hit with because of some data crossing the threshold maybe. And then it calls Paul that through the Kafka bus, saying that take the action. Now the action, if it is auto scaling, it will scale by invoking the LCM, the lifecycle manager, by telling it that go ahead and scale and add a new video to the LCM, or it will go and call the webhook if it is an alarm. Okay, right. So this is auto scaling and alarm architecture. The next, so now let's see how we will go and define the the auto scaling. So let's also like see it in real time, not just see on the slides. You can see in your network slides. It should be already there if it is already created. Okay, so what we do, we write this scaling group descriptor. That tells you like what are the number of maximum instances that have to be created if a threshold rule is breached. And the threshold rule or the scaling criteria is defined here, where you tell like if it is greater than, if the what is the matrix? The matrix maybe we are using a CPU utilization, and if it is greater than certain threshold, that is say 60, then you go and scale out. Okay, the scale out threshold. Similarly, you have a scale in threshold, like when you need to reduce or shrink your VNF by remove the extra video. And then you have the video reference, like we will be using this Magma video here. Okay. Now, so that is the scaling group. Now, if you want to put an alarm, you will use an alarm descriptor as well, where you tell like what alarm you have to invoke. What is the alarm ID? Say so that the alarm is your CPU threshold that you will use, and at what threshold, that is the threshold is that when the CPU has crossed 80%, you will go and trigger the alarm maybe. So that is your the third thing that you want to do. Few things that are important, that alarms or auto scaling can also only be done on the existing matrices that are already monitored. And you have a threshold to monitor, and if it is an alarm, then you have a webhook as well. So let's go and see in our slice, okay, how it looks like. Okay, so a question to all of you: is your slices ready, or still not ready for a few of you?
Very few of us are ready actually. Like if you see the sheet, it's like 5 or 6 people would be ready.
Oh, so how should we do it now then? So I am
We are working
about to start.
Subhankar, David and I, we can help the ones that are not ready yet, and you can maybe work with the ones that are ready to, and
Sure.
but you take the part of the auto scaling.
Okay. So what? Thanks, Jampatro. So what we'll do then is the participants whose network slices are ready, they can try out in their own slice, and the participants whose network slice is not ready, you look into what I'm showing. Okay, and then we can repeat it when your slices come back. Okay, but if you have any questions, like I will go slow, because I know for participant whose slices are not ready, it is not very easy to follow me if you're not seeing in your own tenant. So I will go slow. If you have questions, stop me. Let's make it interactive and not I'm only the person speaking. Okay, and if you have questions, just you can let me know. You can put in Slack or just put on the chat. Okay, so what we have seen, I mean, that we can auto scale, and also we can send alarms based on threshold rule. So the first thing that we have to do is we have to set these rules in the VNF description. So these are per VNF. So it is important that we define it in the VNF. So and then launch it. But I will not ask you to launch, given that we don't have much time to launch it again. So what I will do is I will show you that it is already there in your VNF descriptor. So thanks you for to this, that you will not have to add it again. So if you go to your say the VNF packages, like go in your UI, the ng UI, go to the VNF package and look for this AGW VNF descriptor, right? So this, or the AGW VNF package. So this is the package which will use, or the instance VNF instance corresponding to this will be scaled out. So what we can see is, if you go and edit, so so there in the right hand side you have a drop down. You just click on the drop down and you can go and edit. So now couple of things that you can see here, right, that I have added already. So when you have used a package to install, it was already there, but ideally when you want to define a new alarm, you want to define a new scaling group, you have to add it to your VNF descriptor, which may or may not be already there in your VNF. Okay, so if I just scroll down and the participants whose slices are already available, or at least who can see this descriptor in their UI, can go to line number 127 and see that we have defined.
Sorry, Subhank. This is for AGW, right?
This is for the AGW. Let me go back again and show you how I came here. So you will see 3 packages in your slice, and I am using the AGW package.
Okay.
Okay, and there is a action button here. You just click on this. It's a drop down actually. You'll go to the edit here and come to line number 127. Scroll down and come to line number 127. So what I'm showing you, absolutely. So what you are seeing here in 127 is I have added an alarm. So you see that a URL is provided. Eventually, this webhook should be where you want to send that trigger. So what I have used a webhook dot site. So if you go also refer to the slide that I have sent, you will see that this webhook dot site I have used to invoke it. Eventually, what you should do when you open this site, you will get this URL, that webhook URL. If you don't have a external alarm engine, what you should do is you should go and use this webhook site, so that at least see this webhooks being called. So ideally, I would have asked you to copy this webhook from here, paste it here, and relaunch. But now, as we don't have much time, and still some of our friends they could not launch it yet, so you just see it here. Maybe your alarms will not work because though the alarms are sent, but because they're not reaching to the webhook because you don't have the right URL, it may or may not work. So we'll see when we are trying it. But it is important to know why it is there. It is the URL where it will be invoked, which will be invoked when an alarm criteria is met. What is the alarm criteria? That I'm saying that I'm using CPU threshold as the alarm ID. That is the name of the alarm. The alarm or the VNF that I'm or the parameter that I'm monitoring is the CPU utilization, and the criteria.
Sorry, I'll have to just one or two questions here. So first question is, it is something like if you have an external monitoring engine, you are throwing the alarms to them, right? This is the way to do it, right? Okay. Yes. And the second question is there a prerequisite on the Vim layer to have certain, for example, notchy or ceilometer configured for it to work, or it is independent of those? It's only at the OSM layer.
Okay, there are 2 parts to this. One is you will need ceilometer or other tools like Nuchi. Why? Because these alarms or matrices work on some or alarms or scaling work on some matrice. So what I'm saying here, that if the CPU utilization goes above 80% of your virtual machine, then you send the alarm. For that, you have to first get that that matrix, right?
Yeah, that is the reason I was asking, because this AGW CPU util, so this looks like a keyword which should be coming from a log file or a log which is produced right at some layer. So as you said, I can relate it now, I guess. So this AGW CPU util, this should be a keyword which would be coming from the lower layers, right?
Yeah. So you are also monitoring it here somewhere, right? So you have also put your monitoring stuff. So just a minute. So you have given the name here. So what you are
Okay.
actually monitor, no? So
Yeah, got it.
so all my monitoring has been given an ID. So
Got it.
when I'm saying AGW CPU util is actually this monitoring parameter that I'm using.
Perfect.
So it
Perfect.
is
It's clear.
all here. Okay.
Okay, thanks.
So now we have this CPU utilization matrix that is being used for the threshold. Okay, and I'm given it a name also, this CPU above threshold, and I'm saying that this is the parameter. So this is like, what I'm saying is that if my CPU utilization goes beyond 80%, then I will use this or this rule will be triggered. And then I also mentioned about the scaling, auto scaling or the scaling group, right? So if I come down, down. Okay, here, line number 260 onwards. Okay, so we have defined the scaling group. So what I was showing you in the slide also, that it has a maximum instance. What is the scaling policy? Like I'm saying this again. It is using this AGW CPU util as the monitoring parameter. Then I'm saying that I'm giving you a threshold rule, which is like if it is greater than 60%, then you scale out, and it is less than 10%, then you maybe scale in or something. Okay, so what, if I can summarize what I was telling you here, is that I have defined a scaling group that is telling me that if my CPU goes beyond 60%, then it will scale out. And if it goes further than that and it crosses 80%, then an alarm will be sent. So I'm repeating, if it crosses 60%, then your scaling will happen. But if it goes beyond that, it is 80%, then may alarm may be raised. So if we can relate with a real life example, it will be like, I'm saying that if say if there is a problem happens and CPU is increasing and increasing, I will first try to give more resources in my own Vim by adding a new video to the VNF. But if it goes beyond that, that means it is out of the control of OSM, and a human has to like take control of this and take some manual action. That is why I'm sending an alarm when it is 80%. Right, so that is how, like to have a real life scenario, you can have both the auto scaling and the alarms put together, but with different threshold conditions or threshold values, but the same matrix. So you can also do it with multiple matrices, like you can have say memory, you can have the input output packets, and now the SNMP agent matrices that it is monitoring. The SNMP agent matrices are still not integrated here, so you cannot scale. So you can see in a Grafana dashboard, but you cannot scale it, or you can see it in the Prometheus dashboard, I believe, but you cannot. It is not further integrated. So the SNMP adapter has just come in this release, and it is already collecting the SNMP matrix, but maybe in the next release we'll integrate it further to use it for scaling and other purpose. But the infrastructure matrices are already there. You can use them for your scaling and alarms. Any questions up to this point? If no, then we can get into the actual scaling part of it to see things in action.
So Subhankar, just one thing, the last point which you just mentioned, the infrastructure metrics are in place, but the SNMP metrics are not in place, right?
Yes.
SNMP based actions are not in place, right? This is the
SNMP based actions are not in place because SNMP matrices are coming to Prometheus. You can see it in Prometheus dashboard, but not integrated further. So it cannot be used for scaling right now in release 8. But release 9, it will be integrated further to be used here as well.
Okay, so so that means automated action is not possible in case of SNMP metrics, but in case of infra metrics, it's there, right?
Absolutely.
Okay, thanks.
Okay. Now we have a very nice roadmap. So we call it as a is part of the closed loop automation or the closed loop self-learning mechanism that we want to build for OSM. So this is just the start of it. That means through rules, through policies, we are able to scale and add alarms. But we want to go beyond that, and I will be talking about that in this session. But before that, if you already have your slices ready, few of you, I think you already have your slices ready. So let's see things in action. The participants whose slices are not ready, they have no choice but to wait. But once their slices come back, say they come back within this session, I can help you. But if they don't come back within this session, then we can work on Slack and work offline to get that ready in the Hackfest time, either today or tomorrow. Okay. So let's start. So the first thing that you need to do, if I can show you like where are my instances. So I believe you should have these instances already available if your slices are ready. That means you should have the EPC slice, which is based on HW, and the orchestrator slice, which is based on the Magma network. So you should have two networks, not slice, two network services in the network slice. So you have one network slice, Magma slice. I put 17 as because this is my user. And so you can put it so that you can distinguish better in your in the Grafana. Okay, but otherwise, if you don't put also, there is a way to find out. Don't worry about that. But this network slice will has two network services, and we'll be using the AGW network service. Okay, so if I go to my Vim, my OpenStack, 17 is my ID. So here you should see two VMs already. One is related to the AGW, and this is what we'll like to scale. And we'll use this IP address, the external IP address, to get inside and stress it. So what we'll do, because we are using CPU as my matrix, so I need to go and stress the CPU so that it goes high and high and it crosses the threshold. That is what we want to do. For that, let me go inside this. So what we have to do is you have to follow the instruction that I have given. So I hope you are able to follow me, and if you already have your network slice created, you are able to also use it and see what I am showing you here, right? If not, questions, just ask me. So if you see from here, slide number 14, the first thing is, you have to get this these two network services up and running in the slice. And then in that you have to find out what is your IP of the HW, okay, in your Vim, and then go in the machine, the management machine, right? You might already have the management machine where you can enter through your own credentials, that the credentials that have been given to you for login to other places, your user ID that you can use to get inside. So what we have to do, so OSM Hackfest. This is my address. We'll go here. So as I told you, this is the VM, right? So this is your VM. This is the orchestration or the management VM that we have. You know, from there we will go to the AGW. Okay, so how will we go to the AGW? For that, we'll use this this command. That means we'll SSH into AGW, and the IP address here is actually this IP address, that is 14, right? So this is my AGW IP address that you can see in your Vim once you get inside. Okay, let me know if I am going very fast, you are not able to understand. So why I am going inside this AGW VM is so that I am able to stress it, right, and see that matrix. So what I will do, I will go inside this, and the password is Magma, right? So username, password remains same. It's all written in the slide as well. Okay, so I have got into this virtual machine. You cannot directly get into that virtual machine. So I am repeating, you cannot, you don't have route to get into that virtual machine. You have to first log in to the management machine with your credentials. From inside that management machine, go to that AGW VM using this command that I have just shown you. Okay, Magma is the login and Magma is the password. Now, for this to stress, we'll use this command. This is a very normal command for stressing the CPU. But before that, let's see how the matrix look like before the stress is happening. Okay, the stress is started. So for that, I hope you know how to go to Grafana. Okay, so if you don't know, just copy your OSM orchestrator's IP address, put it here, and the port number is 3000, and that is common for both the orchestrators, you know, like 12, and I think the other one is 35. So it remains same for both of them. So depending on which orchestrator you are in right now, just put 3000 as the port, and you will get inside this. So admin is the login and password, but please don't change the password. I'm repeating, please don't change the password, otherwise everything will stop, right? I mean, everything is now through admin user, so you should be very careful. Don't change the password of admin. Just if it prompts you to change the password, just skip it, okay, and get a login through admin under admin. Once you are here, you will see all the different dashboards that are created till now. Preferably, you should give your username or the number corresponding to username, so that it is easy for you to identify which one is your dashboard. So 17 is what I'm using. So I will go here, and if you see, there are 3 dashboards that are created. These are automatically created. Like, we are not creating these dashboards manually. Whenever it would have been told to you on the monitoring session as well, and I'm repeating, whenever a network service is created, the corresponding dashboard is also uploaded in Grafana automatically by OSM through the Mon dashboarder utility. So you will not have to do anything, and it takes some time. I think around 10 to 15 second it takes to get the first matrix. So you have to be a bit patient when it's coming for the first time. But for people who have already having the slice up and running, you should already see this CPU, memory, and the packet input output. Okay, so these are the matrices you can. Question.
Yes, Subhankar. I logged into the Grafana using 3000 port, and can you go to the home screen? What do we have to search for anything? Because on the home screen I cannot find any dashboard as such.
What is your IP address? What is your IP address? 12 or 35?
Dot 12.
Dot 12, right? So I'm also in 12. Okay. If you see that the first screen, go to home on the top left here.
Okay.
And if you click here, it will take some time depending on internet speed. And then you'll see the list of dashboard. Now the biggest problem, I will not say problem, I mean something that needs to be enhanced, is that we are all logging through admin. Grafana is still not multi-tenant. We are considering this as a feature. If you are attending our tech sessions, you will know that this is something we are actively discussing. But now everything is like through admin. So I am warning each of you again, please don't change the password, otherwise everything will stop. Nobody can work further on this, right? So what I am telling you,
I have to go to my tenant, right? The slide is slice 8 was my tenant, for example, _8.
Yes, if you, yeah, 8 is here, right?
Yeah, I can see
this one.
Yeah.
Okay. So 17 is mine, so I'm going to 17. If you have 8, you should go in 8, right? You can change the time window. It is showing for last 1 minute, but preferably I will say 15 or 30 minutes is a good time to see if your matrix is collected enough. So you will see this kind of very nice filled in graph, and it will show you so we'll primarily play with CPU. I mean, the other matrices you can do as well. You can do offline while you are back after Hackfest. If you have a problem, you can reach out to us. But today we'll only use CPI utilization to show that one matrix how we can use. So we have put this in your in VNF descriptor. We have put that all the stuff, etc. When I say all the stuff, that means the threshold, the rules, the alarms, etc. We have all put. We have seen that. Now we'll see this in action, how it works. Okay. So what we'll do, we'll keep on watching this part, but if you have already gone to the AGW slice, let me repeat again how you will go to AGW slice. You have to first get into this VM. This remains common for all of us. This is the management VM. Log into this management VM with your OSM Hackfest login and password, which is I think is the same. Get into that user, and then find your actual AGW IP, external IP address, OSM external IP address. That is, it is 14 for me. You can find your own address and then replace it. If you're following my slide, so I'm at slide number 17 right now. You can replace this IP address with your own IP address, then magma this and get into this. Why? Because we want to stress this VM. We want to increase the CPU. In a production system, might be the application running inside it will do it, but now because there is no traffic to this system, so we'll externally try to or stress it, forcibly stress it using this command. So what we'll primarily do here is this. Okay, we'll go here, play this command. I'm already inside. No, I'm already inside. Okay. Yeah, I'm already inside magma. So I will just run this yes dev null. This is to increase the CPU. Before increasing the CPU, you can use a top command. You can use a top command to see that your CPU utilization is primarily around 6.2% for me. So it will be somewhere similar to that. So it will be less than 10% for you now. So okay. So if I put the top command, then it will start stressing it, and it will slowly go high and high and high. So if you put the top command now, so here it is showing 90%, but the matrices will not directly shoot to 90%. It will take some time to shoot there because it has a collection interval as well. Okay, what does this mean? It means that it doesn't collect every millisecond or microsecond. It collects 10 seconds time. So there is this considerable interval. So from the time you actually start this stressing to the time you start seeing it here will take some time. Okay, so now you're seeing it 3%, so it should reach 60% first for the auto scaling to trigger, because that is the threshold target we have set. Second is it should reach around 90% or 100% for this 80% to breach for the alarms to happen. Okay. Alarms you may not see because the webhook may be not correct for you, and I will not advise you to change webhook and reinstall because it's taking a lot of time. You can of course do it later after the Hackfest is over, or even tomorrow if you want to do it, you can do it offline, and if you have any problem you can reach us. Okay, so these two features, they work. Okay, so now the stress is happening, so it will take some time to stress, but in the meantime, let me tell you a few other things. So one is that I told you to use the stop command. If you are already aware of this, that is okay. So it gives you the different information about each process, memory, CPU, etc. But the yes is now 98% is stressing this particular VM. Okay, it will take some time to scale. At the meantime, let me just tell you a few more things about this. One is I have asked you, to use this webhook portal. Also keep this open so that if this alarm comes in, you can see it here. Okay, you see it has started stressing now. Okay, 60%. In my system, it has reached 60%. If you are already doing with me, it would have either already come for you or it is going to come, right? So it was somewhere around 3%, between 3 and 4%. It has suddenly shoot up to 60%. So now somewhere the scaling should start. We'll see the scaling. It will start. So now initially you will have only one video, one for AGW. If the scaling happens, you will see another video coming in. Let me, either you can see it in the log or you can refresh and see it here also. Okay. So you see here that video 2 has started coming in. Just 0 minutes ago, video 2 has started coming in. Okay. So my first rule of scaling, of auto scaling has triggered. 60% has breached. Scaling has started. You have seen the new video here. And interestingly, it will pick up the IP address of the new video and also start monitoring it, which was not happening in the last Hackfest, but this is something we have fixed it here. The feature was there, but there was some bug, we have fixed it. So what you should also see in some time that there is another line that will come here, which will show that the CPU of the scaled out video is also getting monitored here. Okay, but one thing that has already happened is the scaling has already started. Okay, already happened, not started, has already happened, is already complete. The next thing that should happen is somewhere this the alarm should come in. This is when it crosses 100%, that means it's above 90%, it should come here somewhere. Okay, it will come somewhere here in a minute. Okay, if you see that the next alarm has also come in, so it is 5:35. What is the time? Okay, no, 5:35 p.m. It's an older alarm. Okay, so the alarm has not come in, but I am also not sure alarm will come because maybe the webhook URL I have not given correctly. But what you have seen here, what you will see at least here, that the other item that has started scaling, that will happen. Alarm should have also started coming in, but for now you cannot see it because maybe your webhook address is not correct. Once you give the correct webhook address and reinstall, and the webhook address will be the one here, right? So this is your webhook address. Once you give it, that should start coming. For me also, it may not come. Maybe the address is not correct. Okay. But what you see here, this yellow line, the new line that just started coming in here, that is the this yellow line here, the yellow line here, yellow and red line here. So the additional video that has started, coming in, the additional video that was created, that That's video's monitoring has also started. That is the good part about this. So we have seen the scale out. The alarm is not coming for me as well, though it would have been triggered because I have not put the right webhook address here. That is the reason. Do you have any question? Otherwise, we'll start scaling it down and see that like the extra video is deleted. Any questions you have now?
Yes, Subhankar, my graphs show exactly as yours, so it's working. The question I had is, you would be scaling it like manually, or whether let's say the CPU goes below 60%, would it be scaled down automatically? Like
Yeah,
at
that we'll
present,
see
what is
now.
the
That is exactly what we'll see now. So it is, you see, it is 90%, right? We'll stop that yes service. The stress will be removed, and it will scale down automatically. So this is that's why you're calling it auto scaling, right? It will happen in the production. A human will not sit and do scale. You will not see the matrix all the time and scale. Okay, but you have a manual scaling facility also. Why this? So there is an API. If you see the documentation of OSM, there is a way to use an API for manual scaling also. The manual scaling is given because, say, you are writing an application. For example, you are writing a machine learning application. Say you are writing an application to not only use the current CPU value, but the predicted CPU value. That means what will be the CPU, say, 10 hours from now or 1 day from now. Okay, so you want to predict and not being reactive. So what we are reactive now, right? So what does this mean? That means we are seeing our MANO evaluator is seeing that CPU has gone high. That is why it has started scaling. So after the damage has happened or the deterioration has happened, I have started scaling out. So that is the normal conventional way of like doing things. But a more or I will say the reactive way of doing things. The more proactive way of doing things will be when I can do it by predicting the future. So that can be done through machine learning. So through machine learning, we'll be able to predict in future, say 10 hours from now or 1 day from now, what will be the situation, and I want to scale. So we have given you those APIs so that you can write your machine learning application or other innovative application on top of OSM, so that you can use the manual scaling to decide when to scale rather than depending on the policies of OSM. So you have both choices: use OSM, you use OSM's policy inside the VNF, or you can use your external APIs to, or the external application to call the APIs. If you're calling the external APIs, let me tell you that it is not dependent on any metrics. It is just as if you're calling an API and it scales, right? It is scale out or scale in based on just an API. Okay, any more questions? Otherwise, we'll start scaling it down now. So you will see this nice UI already, that two graphs, green and yellow. Yellow is the second video 2. Okay. Any more questions? No questions, I think. I will just see in the Slack as well if you have any questions. So Srinivas has a GoToMeeting problem. Okay, some of you have a GoToMeeting problem. I'm not sure who can help there, but okay, let me just go ahead and start removing the scale. So scaling. So for that, let me stop. So it is very easy to remove the stress. So go to the same VM where you had stress it. Use PS minus EAF and grep yes, just to find out your IP address or port. So my port is this one. Okay, it is written here as well, so you can follow this. I think somewhere it should have been written. Okay, just go and kill this process. Okay, just go and kill this. So just find out your process ID here and then kill this process and do a top. So you see the CPU has dropped from 98, 99% to now 2% for me, I think. Now where is my yes? Where is my? I mean, the overall CPU is less than 1% anyway. It seems. Okay, the topmost is 0. So what I'm saying that if I stop that service I have used for, or the process I have used to stress the CPU, I have killed that process, and my my stress is gone. CPU has come back within 1% utilization, and you should see it here as well. So it will again take some time. As I said, that there is a refresh time. After it will stress, it will come down, and you will see that scale in has started happening. So it will not scale in now, but as soon as like it comes down in a few seconds, it should scale down. Okay. Okay. So it has not scaled down yet, but it will scale down in a moment. Okay, so rather than staring at it and keeping on watching it, let's do something more interesting. Let's see what are the features that are coming in upcoming release 9 and onwards, right? So, and this is where as a community member you can participate. You can pick up some features and develop and contribute. You can work with us to contribute together. And also, if you don't want to just contribute the code, I mean, you can participate in our discussions in enhancing the design, proposing new features, and so on as well, right? That is also possible. So okay. So what are the new proposals that we are bringing for service assurance? So the vision is to have the closed loop automation. So bringing in more intelligence from the current situation where we are reactive to becoming more proactive is where this entire closed loop automation is going. So the closed loop automation is to give brain to the network. That means so like a human body, right? So in human body, what happens is if there is some problem, so I have the capability to self protect myself, self heal my body. That is a God gifted capability every human body has. So it has a core closed loop in itself. It sees, it learns, it protects itself. The same can be done for network, or eventually it is happening also. Why it is so important? It is important because with this you are able to like create a complete autonomous network and have the human out of it. So all the day-to-day operation can be automated through the scripts, through this machine learning, through the intelligent applications, and you can completely if not completely, at least partially remove the human intervention and the time it takes to correct. So the quality of experience that of the service that you want to have will be much better than what you are having today. So 3 things that are important. Observe, that means you should have a better metrics collection capability. So we have, as I was showing you, right, we have the infrastructure collection capability, and to some extent VNF specific SNMP metrics SNMP metrics capability as well, monitoring capability. So these can be the ground or the kind of the foundation for the next step. That is, decide what is the action that you have to take. You have seen that the policy that you have defined, that it crosses the threshold, you want to do something. It can be based on this kind of rules, or can be based on machine learning to decide what is the action that I have to take, and then go and act. You have seen the actual scaling happening, right? So that is the second thing, the third thing that will happen. So this 1, 2, and 3, and then the feedback. That means if I've acted, whether that has solved the problem or not. So you have seen that first we have auto scaled, but that has not solved the problem. It was going up and up and up. Then we have sent the alarm. So this means that the observe, decide, and act is nothing but your is a way to protect yourself from some unusual, unwanted condition that can bring down the network, or bring down the quality of experience of my users who are enjoying the service. Okay, so how this will improve? So we wanted to create a more scalable auto scaling. So this is where the new architecture is coming up, and you are all welcome to participate and help in contributing. It's a big architecture change that is happening. That means today everything is concentrated on MON. So MON evaluator decides what is the action that have to take. It decides when the threshold has crossed. It decides what action has to be taken and sends it to poll. We wanted to make it more decentralized. That means the VNF can be taken through the Prometheus alert manager. VNFs can send their own alarms through SNMP, okay, or Vim can send its own matrices, right? And it will go to Paul, and then this thing will happen. It's a more decentralized. Like I have an alarm, I have an alert, I will send it, irrespective of I am a VNF, I am a Vim, or I am just a VNF, external VNF alarms like an VNF having an EMS. So what I'm saying that there will be alarms coming from multiple places, and not only the MON who is deciding when the alarm will happen, and then it will go to the poll and so on. So it's more decentralized, more scalable architecture. So yeah, you have a new alarm source, just add it here. That is what we want to do. Next is some other very interesting features that we are talking about now. So the biggest move is the machine learning. Not very easy to do, but the idea is that can I detect the anomalies, not based on a static threshold, but through machine learning. Things that we want to do, that we want to remove the thresholds completely. You have seen that I am putting threshold 60%, 80%. How you know it is 60%, not 65% or 66% or 55%? So it is purely based on domain experts' knowledge that you are putting those thresholds. We want to remove those thresholds. We want to make it more dynamic. That means let machine learning decide what should be the right threshold by itself. That is an dynamic threshold. Predictive alerts means that not only alert on what is happening now, alert on future time and date that I was saying. Auto healing is another interesting feature that is coming in. Auto healing means that we are doing the scaling based on matrices that we are able to collect. But what if the VNF itself is dead? Nothing is coming from that. So it is completely unresponsive. So in that case, the healing will be very important, because I have to find out that okay, the VNF is dead, VNF is unresponsive, and then try to reboot it, reinstall it. So that is another feature that we are discussing here. And correlation of multiple metrics. That what you have seen today is just one matrix on which we are able to do. We are able to do OR as well. That means threshold or memory or the packet input and output. But what if threshold and memory and this? So this AND operations are not there, or a combination of OR and AND are not there. So this kind of correlation, not only based on this OR and AND, but also based on say machine learning, if you want to correlate these alarms, right? So these are few things. So mostly like toward the machine learning, towards more proactive thing that we are trying to bring in service assurance. Any thoughts, comments you have now, you can share. Anything that you might be looking into, or you want OSM to have and you're seeing it missing, you can tell me now. You can come to our tech meetings. We are having dedicated service assurance tech meetings where you can come and participate. You can contribute code, or you can contribute ideas, designs, whatever you think will be, you think they will be helpful for the community. So any questions or thoughts you have on this slide, or whatever we have discussed right now? Okay, if you have no more questions or thought, let's see whether it has scaled in or not. Okay, at least this, I can see the CPU utilization has gone down because we had removed the stress. It has gone down, and here if I refresh the Vim, the extra video 2 should have gone by now. Let's see. Okay, so the extra AGW video, that the video 2 has been removed. because of the scale down. So the scaling is also successful now. So what you have seen is an auto scaling. As I was saying, you can do a manual scaling also that is not dependent on metrics. Just you hit the API and it will be scaled in also. Look into the documentation. You can see how to do that. But if you have questions, you can reach out to us on Slack or on email. Okay. So I think that is pretty much what I had. Okay, so this is pretty much what I had. So what we discussed is we refreshed the service assurance architecture. We have seen what are those components in service assurance that are responsible for some of the interesting things that we can do, like auto scaling and alarms. We have seen how auto scaling and alarm works, how you set up thresholds, etc. Then we have seen this in action. We did it ourselves, scale out and scale in. The alarms didn't work because the URL you have to change, that was not possible now. And the fourth thing is we have seen the extra or the roadmap items that we are planning. And I also am encouraging you to come and participate and help the community to implement these features.